Okay, so today we're looking at parabolas. Just a reminder that parabolas are one of the conic sections. In addition to all the other ways we've thought about them, they come from a slice of the cone that you can see right here. We've sliced the top part, just the top part of the cone, to get the parabola. If it goes through both parts, we'd have a hyperbola, which we'll talk about later. If you're interested in some ways that parabolas can be used, you can check out this website right here. We're going to look at some of the features of a parabola. The definition of the parabola in terms of a locus or a set of points is the set of points equidistant from a line and a fixed point not on the line. And we'll talk about a little bit more about that definition later. But what you really need to see now is that there is an important point called the focus, which is right here. That's sort of inside the parabola. And that is where, if you have some sort of a reflector or really anything, that focus is where light rays or sound rays or radio waves or whatever they are would collect, or where they would disperse, which means that you can see parabolas anywhere. Let me try to move this up. Here we are. A satellite dish, this right here is where the focus is, where the waves would come in or go out. In a flashlight, where the bulb is, you can see it's a little bit raised above the surface of the parabola. Again, that's where the light waves, in this case, would shine from. And you can see that the path that the beam makes is parabolic. Here are some examples of parabolas I've seen. Including this one at the Ripley's Believe It or Not Museum, where I didn't go in, but the water makes a parabola path. So what we want to look at right now are parabolas, the four basic types of parabolas. We have already seen parabolas that open up or down, like these. They are parabolas whose vertex form looks like this, right here, where A is the slope or slopishness of it, and HK is the vertex. So you can see right here, HK, just the way we've been doing it, is the vertex. Here's the axis of symmetry. It's the x-coordinate of the vertex. The parabola opens up if A is positive, down if A is negative. All that is stuff that we've done before. But if we want to look at these parabolas over here that open right and left. So here's one that opens to the right. Here's one that opens to the left. This opens this way. This one opens backwards. These parabolas have a different type of equation in vertex form. They are parabolas where the y part is squared, not the x. You can see here we have a y squared, and there's an x all by itself right here. Everything else stays the same. The same idea. The vertex is still HK. The axis of symmetry is now is a y rather than x, because it's a horizontal line. The axis of symmetry runs this direction, so it's a y. So it would be the k value, and the y is stuck in with the k inside the square. Pay attention to that part because you want to be really careful. The k is stuck in with the y right here. K is stuck in with the y, and the h comes last. The h is still the x-coordinate of the vertex, and the k is still the y-coordinate of the vertex. That part isn't reversed, but their position in the equation is reversed. If A is positive, the parabola will open to the right. If A is negative, the parabola will open to the left. All right, if it's not given to us in graphing form, we're going to need to complete the square. I'm going to leave the steps here for you but not talk through them because you've done that a couple of different times. You want to go from the standard form here to the vertex form here, regardless of whether it's an x squared or a y squared parabola. So check to be sure you can do these. And then pause the video, check to be sure you can complete the square and that you're happy with it, and then come back. Okay, check to be sure that you got these answers. All right, on this slide, here's some going the other way. If you have the equation, or once you have the equation, if you've had to use completing the square, you want to think about you want to graph these, thinking about these in terms of transformations. What do you need to do to the basic parent graph in order to move it? So if you look at the one down here, number 4, you want to think about, well, the parent graph is y equals x squared. That's a parabola whose vertex is at the origin, and then it goes to 1, 1, and then it goes to 2, 4, and there's a matching symmetric point over here and here, and so you can take that parabola and draw that. Then you want to think about, well, what does that minus 2 do? It moves everything to the right 2. So the vertex is going to move over 2, the 1, 1 point is going to move over 2, the 2, 4 point is going to move over, and all these are shifting to the right. And then this point shifts to the right, and this point shifts to the right, and now we have a new parabola where everything has been shifted to the right. It works just the same way for one like number 5. The original parent graph for a sideways parabola, this one's opens to the right because the a value is positive here, is vertex at 0, 0, point at 1, 1, point at 1, negative 1, then we're going to move over to this point and this point, and our original parent graph looks like that. Now we want to shift it. Be really careful about this. Where is the vertex for the shifted one? Remember that the 3 right here is the h part of the vertex, and that should really be over with the x. So our vertex is going to be at 3, 2. So our vertex shifts over and up, and then the rest of our parabola looks just the same. There's a point here and a point here, and we're heading out like that. And you can check that with a couple of values if you want. It's easier to pick now a y value rather than an x value. Suppose we pick the y value 1, 2, 3, 4. Well, 4 minus 2 is 2. 2 squared is 4. That gives us 7. So we should be hitting the point where y is 4, x is 7. That's the 0.74. So we should count over 1, 2, 3, 4, 5, 6, 7, 4, and we're up here where we want it to be. So check to be sure, understand the transformation that you're changing your vertex, and you're moving the parent graph. Again, check the rest of them, and then we'll look on the next page to make sure you've graphed them. Think of them in terms of transformations. What happens, for example, down here with the slope? What does the negative 1/3 do? What does the 3 do? What would it mean to be sideways, etc.? So with luck, you have checked, and everything came out, looked the same like it was supposed to. Okay, so check the answers for these and make sure you understand how everything has changed. If you are given the vertex and a point, you can do what, like we've done before, substitute in the values that you know into the basic equation and then use that to solve whatever is missing. So for this one, since it's a sideways parabola, we're looking for x equals a times, oops, not x in there, but y minus k squared plus h. Again, remember the k and the h are reversed where they are. The k stays with the y and the h is with the x. So we know that the vertex is negative 4, 3. So we can put those in. It's going to be y minus 3 minus 4. That's the plus h part, the x part of the vertex. And then we can go and substitute in. We know another point. Well, actually, we know 2 points. We know this one, and you can pick either one. I'm going to pick negative 2, 4. I'm going to pick this one. I'm going to put negative 2 in for x. I'm now looking for a. For my y value, I'm going to put in 4 and solve that for a. So that gives me a full equation of x equals 2 times y minus 3 squared minus 4. And if you're not sure, check another point just to make sure that it all works. If you're interested, you can try this at home with some wax paper. This gives you a very visual idea of this other kind of definition for a parabola. I'm not going to do it here, but it should give you an idea that what you're really looking for is something that, or is a set of points that are equally far from the focus and the directrix. The directrix is the horizontal line that you're making at the bottom edge of the paper, and the focus is the point that you've picked, your point F, right here. Oops, right there. Okay, so some of the new vocabulary that goes with this new way of thinking about the parabola. We've already talked about most of this. This part is all what we've done before. But here, if we're trying to get an equation for the focus, if it's a vertical parabola, if it's a parabola that goes up and down like this, the focus, the direct, and the vertex are going to be all on the axis of symmetry in the same line. It doesn't matter whether it goes up or down. The focus will be inside the parabola all along a vertical line that is the axis of symmetry. You can see that over here. The axis of symmetry goes with h. In this, the focus is h, the vertex is h, the x-coordinate is always h. And the focus moves up by 1 over 4a. The directrix, that line that's down here on an upside-down parabola, on a regular parabola, or up there on an upside-down parabola, has this for its equation. Again, it's the y value that has changed, so it's all in terms of y. For a sideways parabola, if the parabola opens sideways, there we are. If the parabola opens sideways, the focus is inside the parabola with the directrix, with the vertex here, so all of those are on the same horizontal line, so their x value is going to change and their y value is going to stay the same. And you can see that the k is the same here, and the k is the same here, and then on these we have changed the x value. We've gone to the right 1 over 4a to get to the focus, and to the left 1 over 4a to get to the place where the directrix is, which is an x line. I'm not going to go through this with you, but you can see that down here we have the proof for how you get to the focus and the directrix, and you can go through that. Okay, so we would want to write an equation for a parabola with the focus and the directrix, or the vertex and the directrix, or whatever the information is that you're given. So let's talk through that. It would help to make a small sketch of what you're trying to do. So just to get an idea of what the parabola looks like, in our case, we know that the vertex is at 0, -4, so that's down here, and the focus is at 0, -3 7/8. So that tells us that this is a parabola that is vertical and that it opens up, since the focus needs to be inside the directrix. That means that we're looking for an equation that's y equals a times x minus h squared plus k. Well, we know what the vertex is, so we can put that in. Y equals a times x minus 0 squared minus 4. That's using the h and k. So we're at y equals a times x squared minus 4. But now we need to find that a value. That's where we're going to go back and use the equation for the, or use the expression for the focus. We know that the focus is h and then k plus 1 over 4a. We don't really need the h value right now, but we know that -3 7/8, which is the y value of the focus, should equal our k value, which is -4, plus 1 over 4a. If I add 4 to both sides, I get 1/8 equals 1 over 4a, which means that 8 equals 4a, so a equals 2. So I can go back and write my equation now. Y equals 2, that's my a value, x squared minus 4. Okay, in this case, we're given the vertex and the directrix. Again, let's try with a sketch. We're going to draw our axes. Our vertex is at 4, -5, so that's down here. And our directrix is the line y equals -6, so that's here. That's telling us, again, this is a parabola that's going to open up from the vertex, away from the directrix, and that the focus must be in here somewhere, and the distance from the vertex to the focus should be the same right in here. That distance should be the same as the distance down here. So how do we use that in an equation? Again, we know that this is going to be a parabola opening upwards, so we know that the form that we're looking for is y equals a x minus h squared plus k. So, and we can plug in the vertex, so y will equal a x minus 4 squared minus 5. Now we're going to go back and use the equation for the directrix, which tells us that y equals k minus the 1 over 4a. The minus is there because now we're below the vertex, not above it. In our case, we know that the directrix is at -6. Our k value was -5 minus 1 over 4a, and now we need to solve that for a. So I'm going to add 5. And get that a equals 1/4, and then I can go back here and write my equation. 1/4 with x minus 4 squared minus 5. Here's another one. Try that. Vertex -2, 1, directrix x equals -3. Since the directrix is vertical, you know that this is going to be a sideways parabola. The vertex is -2, 1, so it's here, and the directrix is out here at -3. That means you want to start with x equals y, x equals a, times y minus k squared plus h. So try that and see if you come up with the same answer. So first plug in the vertex information. You know that x equals a y minus 1 plus, minus 2. Then use the fact that the directrix equals h minus 1 over 4a, since this is vertical and the direct and opening right. So then we end up with -3 equals -2, the h value of the vertex. So -1 over 4a equals -1, and again a equals 1/4. So our equation is x equals 1/4 y minus 1 squared minus 2. And here's your homework. And when you're done with these, here are ones for you to graph. You can try these, and you also have the worksheet that is your homework. You can try both sets of problems. These have the answers in the book if you'd like to check them.